All right, so here we're going to deal with 4 examples in all, but we're going to use the first 3 of them to help us with example 4. So example 1, we're going to deal with this part here. So it says, in a truckload of apples, 5% of the apples contain worms. If we pick a random sample of 10 apples, what's the probability that exactly 3 of them have worms? So what's the probability of that? So with it, first off, we look in and say, okay, is this really a binomial distribution? Is it really? Is it really, really, really? So if we're talking about trying to have to contain worms, we have 2 different situations going on. Either they're going to contain worms, which is success, or we have failure, where they don't contain worms. Right? So we have 2 of those things. Do we have a fixed number of trials? Yes. There's 10 apples. So when we're looking at the number of worms and apples and stuff, we say there's 10. So that means n is going to equal 10. That's our fixed number of trials. All right. So when we do this, if we pull out 1 apple, that doesn't affect the other apples. So we know it's okay. They're independent. But then the probability is it the same everywhere I go? It is. It's 5% of the apples contain worms. So no matter what, 5% of the whole batch is apples. It's worms, apples with worms. So yes. So our probability of success, which is the apples that contain worms, is 5%, which is 0.05. All right. So when we go into Desmos in a few seconds, we're going to have it where we do binomial dist. We have our n and our p. Again, we know n is 10. We know p is 0.05. But one thing you want to notice underneath it, it's going to have a thing called max. Sorry, min and max. And again, this is in Desmos. So in Desmos, it's going to be look different than it does in the TI-84. But yeah. So to find our max and our min, we have to take a look at the last thing that they gave us here, which is this part right here. So exactly 3 of them, of those apples, have worms. So if we say something is exactly 3, just like we said before, like exactly 60, we say it was just 60, right? So this is just 3. So it doesn't go above 3, it doesn't go below 3, it is just 3. So for our min and our max, we don't go above or below, we just do 3 for both. All right, so let's go ahead and pull in our we call it our Desmos calculator here, and let's go and do it. All right, so we pulled it up. Here we go. So with it, just to give you guys an idea of what's going on, we're going to click on the keypad here. We're going to go to functions. All right, and it's a little off there, so you can't kind of see everything, but it's okay. We have trig, stats, distributions, and miscellaneous. We're going to go to distributions. So click on distributions right there if you're not already there. And then we're going to go to binomial dist, binomial distribution. All right, so we click that. And the great thing about Desmos that it doesn't happen in the 84 calculator per se. They tell you what should go inside the parenthesis. So trials is there, so probability of success is there. We said the number of trials is 10. So that's what goes first. Put a comma, because there's a comma right there too. So after trials is a comma. And then we put 0.05 for the probability. That's what we said right there. Close that off. And we're like, okay, it didn't do anything. Oh my gosh, what are you supposed to do now? And so we're like, okay, well, we're good. We're going to click on this part, find the cumulative probability. We said our max and our min is 3. That's 3. That's 3. And guys, that's our probability right there. The probability of getting just exactly three apples with worms. So here, I'm going to use P of X for our probability. So we're going to round that, because remember this 7 right here will take this 4 up to a 5. So we make that there. So we have a probability. I'm going to bring it to a percent also. And everybody hopefully remembers how to do that. So if you don't, remember all you're doing is just taking this decimal. We're moving it over 2 decimal places to the right. So technically here we have 1.05%. We're like, okay, cool. So what does that 1.05% mean? It means there's a 1.05 chance of having exactly 3 apples with worms in them. So that's not much at all. All right, so let's go to example 2.